Open up your books to page 259. Today we're going to be learning about the least common denominator. Least common denominator in fractions is useful when you are adding and subtracting and you have two fractions with unlike denominators. By the way, the least common denominator is useful, or is found by finding the least common multiple of the two numbers. So let me illustrate this for you as we look at example 1. This is a real simple one, but if you are told to equate 3/7 with a number over 35 as a denominator, you would know that you need to multiply the 7 by a 5 and the 3 by a 5. And the reason you figured out the 7 by 5 is because if you take 35 and divide it by 7, you get the factor that you used to change this up to a 35. 3 by 5 would give you 15, and there's your answer. 15 over 35 is your new fraction. Example 2, what if you have a variable within the fraction? It's not hard. Look at your 18a squared and compare it to your 3a. In order to convert 3 to 18, you have to multiply it by 6. And in order to convert a to AA, you have to multiply it by a. Therefore, we multiplied 3a by 6a, which gave us this item here. We're going to have to do the same up there. And you should have ended up with 48a. That shouldn't be there. 48a. Sorry, miscopied it. 8 over 3a was what I should have started with. I apologize. Okay, that's example 2. All we're learning right here, this section, is how to change something to a different denominator. Example 3. 2 over x minus 5 is equivalent to what over x minus 5 x minus 1. Now I keep saying this, and there's some of you that just aren't x minus 5x plus 1. Some of you that just aren't hearing me. X minus 5 is a complete item. X plus 1 is a complete item. Here, I'm going to show you something really quick. If I asked you to reduce this next one here, and I'm just kind of sidebarring for a second, what I'm seeing some of you do, I'm seeing some of you go like this. And you're giving me answers like this. That's incorrect, folks. You cannot pull something out of its pairing with a number, okay? The only thing that these two items share in common is a 1, okay? You can't break up this relationship that you see here, all right? This is a complete item, okay? This does not work. Back to where we were. How did we cause x minus 5 to become x minus 5 times x plus 1? Well, we multiplied x minus 5 times x plus 1. Do the same up here. In doing that, you should have found that the top becomes 2 times x minus 1 plus, good grief. Sorry. Okay? Watch your signs. Apparently I'm having a sign issue today. Moving on. The reason for all three of these examples is to show you that you multiply by stuff, generally, in order to change denominators of fractions. And example 4 is going to give us a little bit of practice time. And I'm going to show you how to do it. 3/4, 11/30, 7/45. What is the lowest common denominator, otherwise known as the least common multiple? The easiest way to do this is to prime factor. I know this is an easy one, but prime factoring is pretty helpful. If you prime factor this, you'll get 2 times 2. If you prime factored 30, you get 2 times 3 times 5. And if you prime factor 45, you get 3 times 3 times 5. Y'all know how to prime factor. We've done that for several years. We've prime factored 4, 30, and 45. Why this is useful is you take the greatest power of each factor that is within the prime factoring. There's 2's. This one has 2, 2. This one has 1, 2. The largest of the 2 is 2, 2. 2 to the 2 squared, 2 to the first. The largest power is 2 squared. This has a 3. This has 2 3's. The largest power is the 2 3's. No 5, 1 5, 1 5. So you end up with a lowest common denominator of 180. 2 squared times 3 squared times 5. You would have found out that that's 180. Okay? Again, you're given items that you need to factor, or items that you need to convert the denominators. Prime factoring is extremely helpful. It gives you all of the factors. You list the greatest power of each item that appeared. 2's were here and here. We need 2 2's. 3's were here and here. Greatest power is 2 of the 3's. 5, 1 of those. All right. Numerically, that's the easiest method to do it. But when you start looking at example 5, this is when I think some of you are going to derail on me. Here we go. Example 5. Example 5 is telling us to find the lowest common denominator of 3 over 6x minus 30 and 8 over 9x minus 45. Okay? 9x minus 45. All right. If I factor this item here, 6 times x minus 5. The x minus 5 cannot be factored any further. But this can become 3 times 2. There's a reason why I'm showing it. You'll see it in a second. If I factor here, 9x minus 5. The x minus 5 is completely factored, but the 9 is 3 times 3. Okay? Greatest power of any factor that appears. The 2 is a factor. The 3 is a factor. The x minus 5 is a factor. Okay? The 3's are here. The x minus 5's are here. Okay? 2 appears once. 3, greatest power is 2 of them. And x minus 5 only appears once. Okay? So the answer is 18x minus 5 would be the lowest common denominator you can convert this to. All right? converting these items requires you to factor, and then factor any whole numbers that were pulled out into primes, and then again, use the biggest power. So 2 squared, 2 cubed, you would choose 2 cubed. Since this x minus 5 only appears once, it's just in there one time. Okay? We're going to go ahead and move into example 6. Rewrite 9 over x squared minus 8x plus 16 and 5 over x squared minus 7x plus 12 using their lowest common denominator. First, let's factor these and see what we come up with. This looks like it's a perfect square. X minus 4, otherwise known as x minus 4 squared. Let me test it. X squared, negative 4x, that does give me the negative 8 in the middle. Negative 4 by negative 4 is a 16. I have just factored this. This guy is going to be x minus 4, x minus 3. Okay, factored. All right. The factors are x minus 4 and x minus 3. The greatest occurrence or power of x minus 4 is 2 times. Twice here, once here. So that means x minus 4 is going to appear twice in the new denominators. Okay? Any other factors? Yes, x minus 3. X minus 3 appears once. So it is going to be placed in each denominator. Now the question is, how do I convert this to this? Well, if you recall, this and that are the same thing, which we already have over here. The only item that is new to the party is x minus 3. So what we did on the bottom was multiply by x minus 3, which means we need to do the same on the top, giving us 9x minus 3. On the bottom, this is the same as this. And how we converted this to this was by multiplying this piece by x minus 4. So since we did that in the denominator, we're going to do the same thing in the numerator, which gives us a new numerator of 5x minus 4. Okay? Therefore, this is your new version of the one that started with a 9. 9 times x minus 3 over x minus 3 times x minus 4 squared. You could avoid writing that twice. That would be a whole lot better, but I just wanted you to see it. And this item, converting this to that, required that we multiply in another x minus 4, because here there were 1, here there's 2. There it is, giving me this new fraction. Now you have changed to the new denominator. Okay? Take your time. Be very, very careful that you don't do any weird reducing or changing. It has to make sense. It has to follow the laws that I've shared with you. Lowest common denominator. I'm going to give you the rest of this time to work on it.